exactly the same, or could be the same, or two columns exactly the same, also the value of this determinant will be 0. Okay, that's the proof. The proof is just, you can go through it. It's okay, we are not going to go through it. That's also the general proof of what we said. Also, there is a huge remark. The determinant of a matrix is equal to the determinant of the transpose. So till the time being, how many remarks do we have? Propositions, 3 of them. If I have a complete row, the value of the determinant is equal to 0. If I have 2 rows equal to each other, the value of the determinant is equal to 0. The value of the determinant of a matrix is equal to the value of the determinant of its transpose. What's the meaning of transpose? Changing rows into columns and columns into rows. Okay? That's the proof. Okay, I will skip it. The determinant of a conjugate matrix. What's the conjugate matrix again? What's the conjugate matrix? Conjugate matrix, the matrix of conjugates in case of complex numbers. Okay? And there is a very important type of conjugate matrices. If you remember, the conjugate matrices, the star matrices, which is called, anyone can remember? You will have to review this part. If you have a matrix and you get its transpose, then a conjugate, it's equal to the main matrix. This is very, very important. You will have to review it. I'm not going to tell you about the name. This is very important part, and I told you about it. Okay. Once more, a determinant of a conjugate matrix, it's equal to the conjugate matrix determinant. Both of them equal to each other. Okay. This is the fourth proposition. Third, if you have an upper triangular matrix, or a lower triangular matrix, ya Faisal, the value of this matrix is just multiplying the elements of the principal diagonal. Just multiplying the elements of the principal diagonal. Okay? This is for upper triangular or for lower triangle matrices. If all I have to do is to get the multiplication of the elements on the row, on the principal diagonal. Okay, count the remarks. This is also very, very important. Very important to know. Okay? This is the proof of the previous statement. Okay. One also of the operations, which is very important operations in determinants. This Mr. Am, determinant of A plus B, it doesn't equal to the determinant of A plus the determinant of B. Then once more. The determinant of a sum of two matrices doesn't equal to the sum of the values of their determinants separated. And here is a proof or a small problem on this. Look to these two matrices. Let's first try to get the value of the determinant of the first matrix. The determinant ده بكام؟
0.
بزيرو ليه عملت ايه؟ لأن في كومبليت رو بزيروز وكومبليت كولوم بزيرو. ولو انا ما حبيتش اعمل كده يا مستر وهاب 1 في 0 0 ماينس 0. So الفاليو بزيرو، determinant ده بزيرو. طيب determinant value of this matrix 0 ليه؟ عشان في كومبليت كولوم بزيروز. وبرضه if you multiply the principal diagonal is 0 minus the second diagonal. Okay? Okay. Miss Sierra, let's get the sum of these two matrices. Getting the sum of these two matrices, it will be 1 plus 0 equal to 1. 0 plus 4 is going to be equal to 4. 0 plus 0 is 0. 0 plus 5 is 5. Get the value of the determinant of this matrix. The value of the determinant is equal to 5, which proves simply the first statement. معايا Mr. Omar? The determinant of a sum of two matrices doesn't equal the value of the determinants of their addition. Okay, that's this is the same proposition. Okay, this is one of the most important slides on the batch of today. Okay, I'm going to talk in specific about the row operation. So do you remember the row operations? The 3 row operations? What are they? Switching rows, multiplying the row by a number, multiplying row by a number, then adding it into another row. So how many operations, Jana? 3 of them. معايا عم؟ Those 3 operations we used previously to move matrices into echelon 4 or reduced echelon 4. These 3 row operations, we used them to know the ranks. These row operations, we used them to solve the system of equations. معايا يا شباب? To get the inverse, these row operations. Remark how they are different here in the case of determinants. First of them, switching rows will develop that the value of the determinant of the matrix will be different by sign. So if you have a matrix and you change it, the rows, the value of the first matrix will equal to the negative of the value of the determinant of the second matrix. يعني لما تقلب الصفوف قيمة المحدد ايه اللي هيحصل لها؟ هتبقى بالسالب. If you switch rows 2 times, the value will be the same. If you make 3 switches, the value will be negative. If you make 4 switches, the value will be positive, and so on. So switching rows, it will affect on the value of the determinant by changing its sign. If you multiply a row by a number, this is the second operation, multiplying a row by a number. If you multiply a row by a number, the value of the determinant will be multiplied by this number. يعني لو انا بجيب B من ال A by multiplying the row by a number, the value of the determinant of matrix B will equal to the same number times the determinant of matrix A. معايا هنا؟ يعني لو انت بتضرب هناك كنا بنضرب في رقم row and added on another row, there will be no difference. But in the determinants, no. If you multiply a row in a number, it will affect it. The following issue, multiplying a row by a number and adding it on another row, it's not going to make the determinants different. So the 3 operations in matrices, swapping rows, it will do nothing. Multiplying a certain row and a number, it will do nothing. Multiplying a row in a number and adding it on another row, you will get equivalent matrices. There is no difference. But in determinants, if you change the position of 2 rows, the value of the determinant will take opposite sign. If you multiply a complete row in a determinant by a number, then the value of the determinant will be multiplied by this number. But Faisal, if you multiply a row by a number, then taking this row in your mind and add it on another row, there will be no change. There will be no change in the value of the determinant. These 3 operations are really very important. Actually, I will use them to simplify the values of huge determinants. This is why we are taking these 3 operations. You will be asked about this part in plenty of places in your exam, about the probabilities of the determinants, how to evaluate, how to play with them. Okay, this is really, very important. Another huge remark. Any matrix, once you multiply by a number, all the elements of the matrix will be multiplied by this number. But if you have a determinant and you multiply by a number, it will be multiplied in one of the rows or one of the columns. Also, if you are taking a common from a matrix, it will come out from all the elements. But if you take a common from the elements of the determinant, it will come out from one row or one column. Okay. Also, if you multiply all the elements of a determinant in a number, the value of this determinant will equal to alpha to the power of n times the determinant of A. Now, if I have matrix A, and matrix A is a 3 by 3, and if I multiply this matrix by 2, okay? So if I multiply this matrix by 2, the final result of the new matrix with all elements multiplied into, it's going to equal to 2 to the power of the number of rows, which is 3, times the value of the main matrix. عشان انا متاكد ان حضرتك فاهمني. خليك معايا كده ثانيه. دي نقطه مهمه قوي. 2, 0, and 1. Okay? This is matrix A. Determinant of A, how do you get the determinant of A? Is going to equal to? Okay. Let's get 2 in A. What's 2A? Multiplying matrix A in 2. So all the elements of this matrix will be multiplied by 2 according to the probabilities of matrices. So it's gonna be 2, 4, 0, and 2. Let's get the value of this matrix. I'm sorry, the determinant of this matrix. So the determinant, let's say this is B. The value of 2A is gonna equal to 2 times 2, which is? What's the relation between the multiplication of alpha A, and the determinant of alpha A, and the determinant of A times alpha to the power of, where alpha is equal to, this is what happened. Actually, the value of this determinant is 1. Here, if you consider alpha is equal to 2, it's going to equal to 2 to the power of 2 times the determinant of A is 1, which is equal to 4. عارف فاهمين بقول ايه؟
بس
اتفضل.
الفا 3.
بس قبل السؤال انت فهمت هنا انا قصدي ايه؟ اوكي. لا طيب هو حصل ليه؟ لان لما بضرب فاليو اوف ديترمنت الرو واحد بس اللي بيتضرب في الفاليو او عمود واحد. بس انا لما ضربت في اثنين ضربت الاليمنتس كلها بتاعت الماتريكس. فبالتالي هيساوي نفس الفاليو تو ذا باور اوف ان. مين الان؟ النمبر اوف روز يا عمرو. دي نقطه مهمه جدا انت فاهمها. هسمع سؤال اتفضل.
لو الالفا 4 مثلا.
Same thing.
4 to the power of 2.
Yes, let's try it. Just a second. Let's try it first. So, if this value is 4, what's gonna be? I will multiply all the elements in 4. So it's gonna be 4, 8, and 4. And once you try to get the value of 4 and 8, it's gonna be 16. And this is true. You already multiplied by alpha is equal to, which is simply 4 to the power of 2 times 1, which is, am I right? Right. If this is 3 by 3, this is 3 by 3, and you multiply by 4, so the value of the determinant after multiplication of this matrix, it will be 4 to the power of 3 times the value of the main matrix. It's actually the value that you multiplied in to the power of the number of rows. Another example which is going to appear right now about comments from a matrix. Just in a second. It will strengthen the idea that I want you to know. Okay? Let's see for this matrix. This matrix elements, please go with me step by step. Farid, I'm sorry. And 2, 4, 6, 3, 9, 15, 5, 0, 5. If I took a number from one of the rows, okay, it will come out from one row or one column. So it's gonna be taking 2 from the first row, so it's gonna be 1, 2, and 3. This value of this determinant, if you multiply by 2, it's gonna be exactly the same. They are similar to each other. Okay, now I'm going to take 3 as a common. I'm just playing with you. The 3 will come out from the second row. So taking 3 as a common, this value and that value will be exactly equal to 2 times 3 times this guy. If I want to get 5 as a common from the third row, so the result will be 2 times 3 times 5. And the value of this determinant. If you, it's okay now, the idea is okay. Why not? مش فاهم بتقول ايه؟
أنا مش فاهم أنا كده اتلخبطت.
اتلخبطت في ايه؟ انا باخد الماتريكس دي شايفها؟ طيب الماتريكس دي زي ايه بالظبط؟ لو انا خدت من الرو واحد رقم مشترك هيديك نفس القيمه. اوكي؟ يبقى انا لما بعمل once we multiply a matrix by a number, it will be multiplied in one row or in one column. Otherwise, it will do what happened here in multiplication matrices. So, if I'm taking an element from this matrix, take it from one row or one column, it will equal to the determinant of this matrix will equal to the determinant of this matrix plus times 2. معايا يا شباب؟ But you don't have to think about it. Just evaluate the value of this matrix, evaluate the value of the determinant of this matrix, you will find them equal to each other once you multiply them two. It's done. Simple. Another, if I want to take 3 from the second row, also it's going to be the same result. Just take 3 from the second row. The value of this matrix, matrix دي مختلفة عن دي مختلفة عن دي. هتلاقي ان الماتريكس الديترمنت بتاع الماتريكس الكبير ده هو بالظبط الديترمنت بتاع الماتريكس ده لو انا ضربته 6 لان عملت how many operations؟ 2 operations. طيب لو انا جيت على الديترمنت ده matrix which is completely different than this one because I took 5 as a common from the last row, you will find the value of this determinant is equal to the value of this determinant by itself. But it will equal to this one by multiplying these numbers. This is how to take a common from elements of a determinant or from more than one row or one column. Okay, these rules are okay. Process to compute a determinant. This is our plan if I want to evaluate a value of a 5 by 5. If I have a 5 by 5 matrix, 5 rows by 5 columns. If I want to evaluate it, it's going to be very difficult. Because mainly 5 by 5, you can expand it to 5, each one of them 4 by 4. And each one of the 4 by 4, you will have to break it into 4 3 by 3. So simply, it's going to be 20 3 by 3 matrices. Yes. But it's going to be much easier if this 5 by 5 matrix or 5 by 5 determinant is an upper triangular or lower triangle. Because if it is an upper triangle or a lower triangle, the value of this determinant will be simply the multiplication of the elements on the principal triangle. Am I right? Yes. Any square matrix, the determinant of the square matrix, one of the probabilities that we talked previously, if it is an upper triangular matrix or a lower triangular matrix, the value of this matrix will be very simple. How to get the value of the determinant of this matrix? Just to multiply the elements of the principal value. Okay? This is under the conditions. If it is upper triangular matrix or a lower triangular matrix, this is right. If it is upper or lower matrices. If I have a full batch of numbers, I will use the 3 operations that I indicated to you. Swapping rows, multiplying row by a number, or multiplying row by a number and adding the result from another row. I will make this manipulation in order to put it on echelon form. What's the echelon form? To be an upper triangular matrix. Once it is an upper triangular matrix, the value of the determinant will be the multiplication of the elements of the principal diagonal. فاهمين معنى كلامي؟ But once you are playing with the row operations, just Farid, keep in mind the differences in switching rows which give a negative sign. Multiplying row by a number, it will be multiplied by the matrix, all over the matrix. Okay? If you multiply a row by a number and add it on another row, then it is not going to change the value of the matrix. Just put that in mind. Once you are very good at it. All this track it's mentioned here. Do elementary transformation. This is what I told you about. Okay, on lines, on rows, such a way to transform A into a star case matrix. What's the star case matrix? The echelon form. Okay, taking into account the changes in the determinants introduced by each one of these elementary transformations. That's what I told you about. If you swap the rows, there will be negative sign. If you multiply a row by a number, remember this number, or rank it, or put it into consideration. Okay, one option is a relation between determinant of A and determinant of B, because you are connecting them. You are exchanging the matrix while you are evaluating the value of these determinants. So, and also you are linking them by these processes. Since the determinant of B is equal to the product of the elements in the diagonal, which means it's an upper, in this case it's an upper triangular matrix, then it will equal to the value, the determinant of value of A and determinant of B will be evaluated. So this is the plan. Look to this problem. Very important one. This 3 by 3, I can do it by little ways. I can use the cofactor method. I can use Sar's rule. Do you remember Sar's rule? How to evaluate by using Sar's rule? It's important. I will multiply the elements of the principal diagonal. 0 times 2 times 8. Then plus the 2 elements of the diagonal. 1 times 6 times 10. Then plus 3 times 5 times 2. Then minus. I will multiply the elements of the secondary diagonal. 10 times 2 times 2. Then minus 3 times 6 times 0. Then minus 5 times 1 times 8. This is Sar's rule. معايا فريق? We already know the rule of cofactors. Okay, choosing in a row, in column, just to explain it. Now I will show you another method. I will manipulate to reach additional form. First thing, or first step I will do, I will make a switch in rows. Then once more, I will raise this row to be in the above position and replace the first row instead of the second row. The value of the determinant will change. So this determinant will equal to the negative of that determinant. That's the first step. Now I need 2 to be 0. How to make 2 to equal to 0? Mr. Omar. I will multiply the first row by negative 2 and add it to the third row. How do I the first row of negative 2 and the second row? The value of the determinant will change. So multiply the first row by negative 2 and add it to the third row. Here we go. The value of the determinant is not changing. This determinant value is equal to that determinant value. Second step. I will need to take 5 as a common from the second row. So once you take 5 as a common from the second row, it will remain. You already changed the value of this determinant. Okay? But it will equal to that one plus not multiplying by 5. So معايا فريق? That's the second step. Now I have this element is 1. I will multiply the second row negative 2 and add it to the third row. Here we go. How to evaluate the value of this determinant? It's going to be very simple. Negative 1 times 5 times 1 times 1 times negative 2. Because this is an upper triangular matrix. The value of the smaller one is just only multiplying the elements of the principal diagonal, which is going to be 1 times 1 times negative 2. Here we go. Plus 1 times negative 5. So negative 5 times this value is equal to 2. شباب معايا؟ اتفضل يا فندم.
هو ازاي الثيرد رو اتغير؟ الثيرد رو كان 268 بعدها
الثيرد رو اللي هو كان فيها دي واحده دي multiply the first row by negative 2 وadd it on the last row. multiply negative 2 plus 2 negative 4 plus 6 negative 6 plus 8. I choose to multiply the first row negative 2 and add it on the last row.
وليه بقى حطينا 5؟ يعني احنا ليه ضربنا الماتريكس الاخيره دي 5؟
ثانيه واحده. انا خدت 5 يعني عايز الاليمنت ده يبقى ببوزيتيف 1 عشان اوصل للستار كيس اللي هي الايشن فور اللي هي الابر ترينجولار ماتريكس. عشان اعمل ده عايز ال5 دي تبقى كام؟ طيب انا شايف ان السكند رول ده اقدر اخد منه مين كومن؟ ازاي خدت منها كومن؟ فاصبح 0 2 و5 سوري 0 1 و 2 اهو. اللي بعدها انا عايز beneath this positive 1 this element is equal to 0. I'm sorry. So I will multiply the second row by negative 2 and then add on the third row. Multiply by negative 2. Negative 2 times 0 plus 0 it's 0. Negative 2 plus 2, it is 0. Negative 2 times 2, negative 4 plus 2, negative 2. أكمل كلامي وأوصلك. معايا يا مستر محمد؟ كده الفاليو دي بقت بكام؟ negative 5.
كده بقت اشبه 4.
صح؟ كده بقت اشبه 4. What's the gain of evaluating a determinant for an issue 4 matrix? The value will equal to multiply the elements of the principal value. Multiply the elements of the principal value. 1 times 1 times negative 2, which is negative 2. معايا بقى؟ خلاص؟ negative 2 times negative 5. جبته كده. بالتالي احسن كتير انا كنت اضرب 0 times 2 times 8 is equal 1 times 6 plus 10 plus 3 times 5 plus 2 minus 10 times 2 times 2 minus 3 times 6 times 6 minus 5 times 1 times 8. Here you have an option to choose source rule or this rule. But if this determinant is 5 by 5, you will have to do this. Do you read me? Okay. أيوة زياد. اتفضل. حد عنده سؤال؟
مش احنا كنا بنعمل رول ثانيه خالص؟
طب أنا جاوبت حالا إن أنا ممكن هنا عندي الاختيار يا إما أعمل طريقة سرس يا إما أعمل طريقة الكوفاكتور يا إما ألعب بالرو أوبريشنز وأوصله لطريقة سهلة أو أحسن. لكن في أحيانا حضرتك هتبقى بقى مجبر يعني لما يجي لي 3 في 3 مش هعمل العجين ده. بس في أحيان تانية أنت بقى هتبقى غصب عنك. أنت بقى يبقى غصب عنك. لو أنت عندك ده مثلا 4 by 4 5 by 5 6 by 6 ما فيش قدامك حاجة تانية كده.
ما ينفعش تفرق.
مش هتعرف هتفك في الامتحان 40 3 في 3 ولا 20 محدد 3 في 3 مش هتقدر.
مش احنا بنعمل الرول كل بس
لازم تذاكر الاول عشان تبقى قادر تماتش تقدر تجري ورايا. طب شباب خلي بالك ان n by n have a is invertible if and only if determinant of a doesn't equal to 0. Okay. Determinant of the product of matrices. This is very very important. ده مهم. خلي بالك كل tiny piece of information that you are taking is really important. In the previous slides, we remarked that determinant of A plus B doesn't equal to determinant of A plus determinant of B. صح؟ هنا determinant of multiplication is equal to each other. So if I have determinant of A times B, the determinant of A times B is equal to the determinant of A times the determinant of A. Do you remember the value of the inverse in multiplication in matrices? AB minus 1 is equal to B minus 1 times A minus 1, which is really confusing. That's what I'm telling you about. The probabilities have to be studied very good. A times B transpose is Jana. It's equal to B transpose times A transpose. Now, how many relations did you take in multiplication? A lot. And it's really confusing. Even me, if I spend some time without reviewing these details, I will lose them. So it needs a continuous revision. Okay. Another remark, another very important remark. A determinant of A minus 1 is equal to 1 over determinant of A. And you usually use inversion. مش انت بتجيب الانفرس؟ ممكن يخبطك سؤال من الاسئله. Maybe he will ask you a question in the exam targeting this part, a determinant of a matrix and the inverse, and you will need this relation. A determinant of a matrix is equal to 1 over the value of the determinant of the inverse. It's really very important. Okay. I want to go with you with the sheet. I'm not going to solve because most of them you can handle them. But there is some remarks which is really important. The first of them is really very easy. This is how to evaluate a 2 by 2. You can do it very simple now. Of course, multiply 1 times 2 and so on for each one of them. Okay, look at this matrix, which is also a joke. He's telling you, يا اسطى خليك معايا. بيقول let A 0A A squared, A minus 1 0A, A minus 2 A minus 1 0. Can you evaluate using Sarah's rule? انت قول لي بقى. ماشي قول. قول. a minus 1 times a minus 1, a minus 2 times a power 2, it's equal to positive 1. خليها معاك يا فيصل. multiplying a times 8 times a negative 2, another positive 1. يبقى فيصل معاه كام؟ شيلوا في ايدك. بعدين minus a squared times 0 times a negative 1, 0. بعدين minus a times a minus 1 times 0, 0. بعدين minus a times a minus 1 times 0, 0. So the value of this is equal to 2. How he is going to ask you about this in the exam? Miss Seda, he will state, choose the right statement for each of the following. ويروح جاي يديلك كده. The value of the determinant A using what he's not going to tell you use what. The value of determinant A is 2. Is it true or false? So you will have to evaluate and then you will choose if it is correct or not. Yes, Miss Seda. Yes, number 2. Number 2.
Yeah.
It's a to the power 2 times a power negative 2. So they will cancel each other as well. Okay, through the evaluation. A to the power 2 times a to the power negative 2. That's really 1. Okay. This is very simple. He's asking you about the algebraic complements. What's the algebraic complement of 3, 2?
2.
I need the algebraic complement of the element 3, 2.
1, 1, 3, 4.
3 and 2. So it's gonna be
1, negative 1, 3, 4.
غلط.
صح.
غلط. لأن حضرتك ما حطيتش الساين. The algebraic complement, it contains the sign with it. أنت فاهمني يا فريد؟ فاهم أنا قلت إيه؟ يبقى هنا في الالجبريك complements، الالجبريك complements يا ندى we choose the element, evaluate the value of the determinant times the sign. You read me؟ عشان كده لما جيت في الجزء ده قعدت اشرح، قريت وصلني كده اروح عايده تاني اشرح لك تاني. انا اللي يهمني في الالجبريك complements انا عارف انك بتعرف تعملها، هتروح على الفيرست رو سكند رو تشيلهم واللي يفضل تكتبه. وانت مش هتكتبه بس، انت يقول evaluate the determinant of this matrix. But times the sign, okay, times the sign. Okay, those are very, very simple. Yes, of course. Okay. As I told you, Farid, the problem is in the exam, he will ask you just only to state if it's true or not. So, if you evaluate it, it's equal to 6, but he's writing to you, the value is negative 6. You will choose, it's not correct. You read what I'm saying? So science here is really very important. Okay? Okay. Look, this slide, or this bunch of group of problems is very simple. Let's look at those ones. Compute using two different ways the value of the determinant. Okay, it's simple. You can use any row or whatever. This is simple. A question, please. Question, please. What is the best choice for evaluating this 4x4? Miss Sulaiman, tell me which option I would go for in evaluating the value of this determinant. What are you looking for? I'm looking for a row. Yes, you are correct. I'm looking for a row with a huge number of rows, or a column with the hugest number of rows, or even better, it should be in the back of your mind, if there is no similar rows, 2 rows or 2 columns. In this way, you don't have to evaluate it. Do I have 2 rows exactly the same? Or I can take a common and they will be the same. في حاجة كده؟ Okay, then which row I should choose or which column I should choose? I think the first row is tempting because it's contained 2 zeros. So you will be dealing with 2 3x3 determinants. Also, the second column looks tempting because also it contains 2 zeros. So it will come up to just only 2 determinants, 3 by 3. Okay, this question is good. He's asking you to justify, Ms. Jana, why the algebraic complement of 4 and 3 is equal to 0. Let's go to fourth row, third column. Fourth row, third column. Is it appeal to you? What's equal to 0?
0.
0 column.
0.
Yes? So it's already justified. A for 4 doesn't depend on B. It's very simple. I will go to the element from 4. Remove 4 and 4. That's the 3 by 3. Try to evaluate the value of this determinant first and see if it is dependent on B or not dependent on B. Determinant A doesn't depend on B. So I will have to evaluate or to choose which one. Okay, let's look at this. Determinant A doesn't depend on B. Is this correct or not correct? Remark that this one is corrected to B. Determinant B doesn't depend on. بص determinant A first of all هتكسبان على مين؟ اكسبان على مين؟ على الفورس رو. لو انا جيت على انا اسف على الفورس كولم، انا لو رحت على الفورس كولم هيبقى مجرد A تايمز الديترمنت ده. اوريدي الديترمنت ده اللي هو الكومبلمنت بتاع 4 باي 4. انت اوريدي عارف اذا كان ديبند اون بي ولا مش ديبند اون بي. يبقى على طول تقدر تجاوب في ثانيه. دي حلوه.
للمره الجايه.
دي حلوه. لا المره الجايه مش حاجه ثانيه. دي حلوه وعايزك تحلها لوحدك. I need you to think about this and to solve it on your own. This is important. Okay?